Hey there, everybody. Welcome back. Our final example for spherical triple integrals. Let's just jump right into it. We had to give you a hard one. Everything's going to start out in x, y, z. We've got our function z squared times the square root of x squared plus y squared plus z squared. Our limits of integration for dz are 0 to 9 minus x squared minus y squared. For y, it's negative square root of 9 minus x squared up to positive square root of 9 minus x squared. And x is going from -3 to 3. What makes me go, why would I want to do a triple or spherical? Well, this looks a lot like radius rho, right? Rho squared is the inside, square root of rho squared is rho. I can write z as, don't forget, z is rho cosine phi. So I can switch this to spherical and it'll be all right. What's it look like in spherical? So let's look at z first. Z is between 0 and the square root of 9 minus x squared. If we square both sides, just looking at the z less than the radical, square both sides and collect all the variables on the left, it shows that x squared plus rho squared plus z squared, not rho squared, x squared plus y squared plus z squared is less than or equal to 9. That's a sphere with radius equals 3. The z being greater than 0 tells me it's not the full sphere, it's the top half of the sphere. So a hemisphere. If we look at y, it goes from -9 minus x squared, I'm sorry, square root of 9 minus x squared up to positive square root of 9 minus x squared. And again, when you got the same thing on left and right, one's negative, one's positive for sandwich inequality, it becomes the opposite value. I solve for y here, and I get x squared plus y squared is less than or equal to 9. This matches that projection of the sphere onto the xy plane. In fact, it is the actual, if we just look at the equator, basically. So that matches, it's still the same. And same with x, being -3 to 3, we know the radius is 3. So -3 to 3 matches that as well. So this is, we're just looking at the hemisphere above z equals 0, radius 3. So we're going to have our full 2 pi for theta, sweeping all the way around. We're only going from 0 to pi over 2 in phi, and radially we'll go from 0 out to 3. So z is rho cosine phi. We square it, we get rho squared cosine phi squared. The integral was, the radical is just rho. So that's what we get there. Notice if we get all the rho squareds together, not rho squares, all the rows together, we got rho to the 5th. And which means none of the limits of integration have variables in them. This is separable. So I did that. I did the d theta and d phi first, not d phi, d rho first, because they're just simple integrals. 0 to 2 pi for theta, rho to the 5th goes to 1/6 rho to the 6th, 0 to 3. I did a u sub on our sine phi cosine squared phi. I let u equal cosine phi. So du equals negative sine phi. If I move the negative over to the other side, make that positive. I can sub out this and this for negative du. And cosine squared phi will be u squared. So I've got negative u squared in there. The limits of integration, make sure you keep them in order. When we had pi over 2, plugging in pi over 2, cosine is 0. And when we plug in pi, or not pi, 0 for phi, we get u equals 1. So the 0's on top, the 1's on bottom to line up with the old limits of integration. I worked through it like with this negative symbol because you can, or you can switch the sign and flip the limits of integration. It is possible to work through it normally, and you'll get the same thing. So the theta goes to 0 to 2 pi. We just get 2 pi. We got 1/6 times 3 to the 6th. And we're doing -1/3 u cubed from 0 to 1. So we got 0 minus 1. Notice if we had changed the order, like done it over here, we would have had 1 to 0. 1 minus 0, but this would have been positive 1/3. And you'll see that in both cases, we have 1 times 1/3. The negatives cancel out here because the 0 is irrelevant. I've got a 3 down here and a 3 down here. That cancels out, replacing those with the 1s with 2 of the exponents there, giving me 3 to the 4th. So pi times 3 to the 4th is 81 pi. And that will be it for 14.6. Peace.